Hello everyone, today we are going to learn about unique factorization theorem. In mathematics, the fundamental theorem of arithmetic, also known as unique factorization theorem and prime factorization theorem, states that every integer greater than 1 can be expressed or represented uniquely as a product of its primes up to the order of the factors. That is, if we have n greater than 1, then n can be written as a product of primes in a unique way. That is, n can be expressed as p1 into p2 into p3 so on into pr, where p1 less or equal to p2 less or equal to p3 so on less or equal to pr. If in this representation, if P1 occurs alpha 1 times, P2 occurs alpha 2 times, similarly P3 occurs alpha 3 times and so on up to if PR occurs alpha R times, then the above equation can be represented as, that means n can be expressed as P1 raised to the power alpha 1 into P2 raised to the power alpha 2 into P3 raised to the power alpha 3 so on and PR raised to the power alpha R, where P1 less than P2 less than P3 so on less than PR and alpha I is greater or equal to 1 from I running from 1 to R. This representation is known as the canonical form or standard form of a positive integer. Now, sometimes for our convenience we equate the exponent of some prime equal to 0. For example, if we have a equal to 2 cube into 3 square into 7 and b equal to 2 into 3 square into 5 square into 11 cube, then we can write a as 2 cube into 3 square into 5 raised to power 0 into 7 raised to power 1 into 11 raised to power 0. Similarly, we can write b as 2 raised to power 1 into 3 raised to power 2 into 5 raised to power 2 into 7 raised to power 0 into 11 cube. By doing so, we can find the greatest common divisor, that is HCF and LCM of two positive integers. Now suppose if we have two positive integers, say a and b, then the canonical form of A is P1 alpha 1 into P2 alpha 2 into P3 alpha 3 so on up to PR alpha R, and the canonical form of B is P1 raised to power beta 1 into P2 raised to power beta 2 into P3 raised to power beta 3 so on up to PR raised to the power beta R, where alpha I is greater or equal to 0 and beta I is greater or equal to 0 for all I running from 1 to R. Now, to define the greatest common divisor, that is also known as the HCF of two positive integers a and b, it is written as a comma b within the open brackets, that is equal to here the first prime is P1, it is P1 raised to the power minimum of alpha 1 and beta 1. It is minimum of alpha 1 beta 1 multiplied. The second prime is P2, it is P2 raised to the power minimum of alpha 2 beta 2 up to so on, it is PR raised to the power minimum of alpha R beta R. Similarly, to calculate the LCM of A and B, it is written as AB within the closed brackets, that is equal to P1 raised to the power, here it is alpha 1 beta 1, in the case of LCM we take maximum of alpha 1 beta 1 into P2, it is maximum of alpha 2 beta 2 to so on, we get PR raised to the power maximum of alpha R beta R. Say for example, if we have A equal to 18 and B equal to 21, we know that 18 can be expressed as 2 into 3 square, right? Similarly, 21 can be expressed as 3 into 7 by unique factorization theorem. Now, we can also express 18 as 2 raised to the power 1 into 3 raised to power 2 into 7 raised to the power 0. Similarly, 21 can be expressed as 2 raised to the power 0 into 3 raised to the power 1 into 7 raised to the power 1. Now, we have to find the greatest common divisor of 18 and 21. By the definition of greatest common divisor of A and B, we have it is P1 raised to the power minimum of alpha 1 and beta 1. Here the first prime is 2. It is 2 raised to the power minimum of 1 and 0, that is 0, into second prime is 3. It is minimum of alpha 2 beta 2. It is minimum of 2 comma 1, that is 1. And here the third prime is 7. It is minimum of 0 and 1, that is 0. And we get 3 as the greatest common divisor of 18 and 21. Similarly, for the LCM of 18 and 21, we have it is P1 raised to the power maximum of alpha 1 and beta 1. Here the first prime is 2 and the maximum of 1 and 0 is 1. Similarly, the second prime is 3 and the maximum of 2 and 1 is 2. Here the third prime is 7 and the maximum of 0 and 1 is 1. We get it is 2 into 3 square, that is 9, that is 126. That means the LCM of 18 and 21 is 126 by unique factorization theorem. I hope you have got this concept very well. Thank you so much.